In this video, we will discuss about the electronic configuration, orbits, shells, and subshells. So we will learn about electronic configurations, orbits, shells, and subshells, especially for those of grade 9 students. So we can say the distribution of electrons of an atom or molecule in atomic or molecular orbitals or shells around the nucleus is called electronic configuration. Or we can say we have an atom having a nucleus, and around the nucleus is shells. So you can say this is the first shell, this is the second, this is second, and this is the third, and this is the fourth. So these are the shells around the nucleus. This is the nucleus of an atom. This is an atom, and this is the nucleus inside the atom. And these are shells. You can say these are shells. These are shells. And shells. This one is also shell. And this one is also. And this one is also. So these are shells around the nucleus. So the distribution of electrons around these shells, distribution of electrons around, you can say the distribution of electrons you can say this is electrons. So how we will distribute these electrons in these shells? This is electrons in these shells, distribution of. So this distribution of electrons around these shells is called electronic configurations. This is called electronic configuration. So the distribution of electrons of an atom or molecule in atomic or molecular orbital or shells around the nucleus is called electronic configuration. The electrons are distributed around the nucleus in various orbits or energy levels or shells. These orbits are numbered as 1, let's say 1, 2, 3, 4, etc. Up to 4, 5, 6, 7. To this. These orbits are represented by K, L, M, N, and so on. So you can say these orbits are represented by K, L, M, N, and so on. The maximum number of electrons in a particular orbit is given by the formula 2n squared. 2n squared. So this is the maximum number of electrons in a particular orbit will be determined by this formula. This is a formula. So we can determine by this using this formula 2n squared. This is a 2n squared. So we can say in this formula the n is an integer which is equal to 1, 2, 3, and so on. The maximum number of electrons in the first, second, and third, and fourth, and 2, 8, and 3 respectively. We can say that the maximum number of electrons in the first orbit. We have first learned that there are shells orbits. So we can say there are different types of orbits. We can say there are the accommodation of electron in these orbits are also different. So the maximum of electrons in the first, second, and third orbits are 2, 8, and 18. In the first orbit, we can say this is first orbit is we can see represented in the first orbit. This is maximum of electron is 2. How? Because we have a formula 2n squared. If we have an orbit, first orbit n is equal to 1, then we can say that this is 1 is equal to 1 squared is equal to 2. So the maximum number of electrons in the first orbit is 2. Similarly, the maximum number of electrons in the second orbit is 8. How? By using the formula 2n squared. 2n squared. So we can put the value of n as the second orbit. So we'll put 2 here. This is 2, and it will be equal to 2 into 4, and 4 is equal to 8. So we have seen that the maximum number of electrons in second orbit is 8. So similarly, in the third orbit, the maximum of electrons accommodated is 18 in the way like this, 2n square. So here we will put 3 because it's third orbit. We will put 3 instead of in place of n. So 2 into 3 square. Also, this will be equal to, so it's 2n square equal to 2, 3 square. So this will be 2 into 9, and that will be equal to 18. That will be equal to 18. So in the third orbit, the maximum electron accommodated is 18 respectively. So we can say that in the first orbit there are 2 electrons accommodated, can be accommodated. In the second orbital, the maximum accommodation of electron is 8, and in the third orbit, the maximum of accommodation of electrons is 18. So this is about the distribution of electrons in the orbits. So if we consider, for example, this is an atom having a nucleus. This is the nucleus of an atom. You can say this is a nucleus, and around this nucleus are shells. The shells around the nucleus. We have previously mentioned like this. So you can say this is the shells. These are shells around the nucleus. So this is the nucleus, which is represented by N, and this is you can say this is the first energy level. This one is, you can say the first. This one is the first. The first energy level, and it is also called you can say K shell. This is the K shell. This is L shell. This is M shell. This is N shell, and so on. So the K shell is the first energy level, and the L shell is the second energy level. Similarly, the M shell is the third energy level. The third energy level, and the N shell, which is this one, this is the fourth energy level. So this is the fourth energy level. Now the question is that how we will distribute these electrons in the shells of an atom. So we can say that we have previously mentioned that learned about this, that we can say that K shells can accommodate a maximum of 2 electrons. K shell can accommodate a maximum of 2 electrons because this is the first energy level. This is the first energy level. First, we can say that this is the first energy level. So you can say this can accommodate a maximum of 2 electrons because from the formula we have learned that that is equal to 2n squared. So we can say this is the first energy level. So instead of n we place 1, so that will be equal to 2. So K shell can accommodate a maximum of 2 electrons. So this is the K shell which can accommodate a maximum of 2 electrons here, like this. So this is the K shell can accommodate a maximum of 2 electrons. Similarly, you can say that L shell can accommodate a maximum of 8 electrons. How? By using the formula 2n square, that will be equal to 2. And we can use this is a second energy level, so we can place 2 instead of n, so we get this equal to 2, and 2 by 4 is equal to 2 by 4 is equal to 8. So we can say that L shell can accommodate maximum of 8 electrons. This is L shell, so we can say that this can accommodate maximum of 8 electrons. Similarly, I can say that M shell can accommodate maximum of 18 electrons. So this is M shell. You can say that this can accommodate maximum of 18 electrons here. Similarly, the N shell can accommodate maximum of 32 electrons. So this is the N shell. This one can accommodate maximum of 32, 32 electrons. Yeah. So we have seen that K shell can accommodate maximum of 2 electrons, L shell can accommodate maximum of 8 electrons, M shell can accommodate maximum of 18 electrons, while N shell can accommodate maximum of 32 electrons. So we can just determine the distribution of electron by simply using the formula 2n square. 2n square we have 2n square. So this is the formula which we can use to determine the number of electrons in various shells, such as K, L, M, and so on. Now let's talk about the concept of S, P, D, and F subshell. So about the concept of S, P, D, and S subshell. So we can say that what is subshell, or you can say orbit. What is subshell or orbit? According to the Bohr atomic theory, we have Bohr atomic theory, Niels Bohr atomic theory, which states that electrons are revolving around the nucleus in one of the fixed circular paths called shells or orbits. So if we say this is an atom, so you can say, according to the Niels Bohr atomic theory, electrons are revolving around the nucleus. If you see this is electron, these are electrons. This is electrons. These are revolving around the nucleus. So this is the nucleus. This one is the nucleus, and these are the electrons which are around the nucleus in fixed orbit. So this circular path, this is called subshell or orbit. So each there are many. You can say this is if we can see that like this. This is a nucleus. This is the shells around the nucleus of an atom. So Niels Bohr theory states also that each shell has fixed energy. Each shell has fixed energy. So this is as you can see, this is a K shell, this is a L shell, this is a M shell. So Niels Bohr said that each shell has fixed energy. These orbits are also called energy levels. This is we have previously discussed it. These are also called energy levels. This is the first. You can say this is the first energy level. This is the. You can say it's the first. This is second. This is third. So these orbits are called energy levels. Each shell is distributed by n value. Each shell is represented by n value. N value, where n is 1, 2, 3, and so on. As the value of n increases, shell number increases. So as the number of n value increases, number of shells, we can say this is increases like this. So when the number of shell increases, the number of electrons, we can say this is electron in a last orbit or a shell. So the distance is more from the nucleus. I can say this for this from the nucleus. So as the distance of electron from the nucleus increases, energy of electron also increases. So this electron is at low distance from the nucleus, like this one, and this electron is for more distance from the nucleus. You can say this electron is near to the nucleus. So those electrons which are farthest or in the last cells have more energy, and the electron close to the nucleus will have low energy. So we can say that the subshell is also the area in which electrons moves within the shell. Subshell, you can say subshell. This is an area in which electrons move within the shell. One or more orbitals in the electronic shell of an atom with the same energy level is called subshell. A shell or energy level is divided into subshells or subenergy levels, where n value of shell is placed before the symbol of a subshell. So there are four subshells. So we say that this is represented by S, P, D, and F. These are the subshells S, P, D, and F. So this are the subshells, and this is the area in which electrons move within the shell around the nucleus. You can say these are shells. So this is shell, this is shell, and subshell is also the area in which electrons move within the shell. Electrons move in this shell. So this is the area in which electrons moves in the subshell. So there are four types of shells, which are represented by S, P, D, and F. And these are spectroscopic terms which stands for S stands for sharp, S stands for sharp, P stands for principal, P stands for principal. I can say D stands for this is D. This D stands for diffused, and F stands for fundamental. S subshell can accommodate maximum of two electrons. While P subshell can accommodate a maximum of 6 electrons. D subshell can accommodate a maximum of 10 electrons, while that of F subshell can accommodate a maximum of 14 electrons. So 14 electrons. So these electrons, you can say if the electrons are in the two electrons in the S subshells are called S electrons. You can say S electrons, and the electrons in the P subshells are called P electrons. P electrons, you can say P electrons, and the electrons in the D subshell are called D electrons. So this is the about the subshell of an atom, in which electrons are distributed in different ways. If we move towards atomic configuration for the electrons in the subshell, so we have previously learned that K shell can accommodate maximum of 2 electrons, 2 n square equal to 2. This is the first subshells. So accommodate maximum 2 electrons, so that is square, that is equal to 2. So the electronic configuration of these two will be simply you can say that 1 is 2. This S can accommodate maximum of 2 electrons, so the problem will be finished here. Also, we can say that the second energy level, which is called L shell, can accommodate maximum of 2 square 8. Can accommodate 8 electrons. So its electronic configuration will be you can say 1 is 2, 2 is 2, so 2p 6. This is a 2. This is 2 plus 2 is equal to 4, and that will be having before, because we have just there are 8 electrons, and 2 and 2 is equal to 4, and we have remaining 2 electrons. So 2 sp 2 will be we will represent here 4, because 2 electrons are remaining, 4 electrons are remaining. So you can say that 1 is 2, 2 is 2, 2p 4. 1 is 2, 2 is 2, and 2p 2s2 and 2p 4. Similarly, so you can say 2s2 and 2p 6. For combination, we will mention that we can accommodate a maximum of 6 electrons. The third energy level, which is M shell, and in M shell we know that the third energy level, so 3 square, and that will be equal to 15. So 15. So if you see the electronic configuration, it will goes towards 3s2, 3s2, 3, 3p6, and 3 d10. So T can accommodate 10 electrons in the third energy level. Similarly, the fourth energy level, which is called N shell, it can accommodate 32 electron maximum. And if you see its electronic configuration of the four energy level or N subshell, you can say that it will be 4s2, 4s2, 4p6, 4d10, and 4f14. 4f14. So here you've seen that F can accommodate 14 electrons of maximum. So we have seen that this is the K shell is the first energy level. It's the K shell, and we will distribute the electrons in this formula. By this formula, according to the Bohr 2n square, that will be K shell will accommodate maximum of 2 electrons, and there are S subshell. So similarly, second L is the second energy level. L shell, which is the second energy level. So it can accommodate maximum of 8 electrons. So its electronic configuration will be 2s2 and 2p6. 2s2 and 2p6. So p can accommodate maximum of 6 electrons. Similarly, the N shell, which is this one, is a fourth energy level. It can accommodate 32 electron maximum. So its electronic configuration will be 4s2, 4p6, 4d10, and 4f14. So this is about the shapes of the electrons distributed in the various subshells. So the increasing order of energy of the subshells belonging to different shells is given. This will be one is has energy less than 2s, and 2s has energy less than 3p, 2p, and 2p has energy less than 3s, and 3s has energy less than 3p, and 3p has also energy less than 4s. Similarly, 4s has energy less than 30, and so on. So we can say that the subshells on this side are of low energy, and on this right side it have high energy. So the electrons are accommodated in the different energy levels by using Afbau principle. Afbau principle. Afbau principle. Afbau principle. According to this Afbau principle, electron feel first the lowest energy from energy shells, subshells, and then high energy subshells. So electron will first feel this one, and will go towards distribution will go towards the right side. So it will first electron will first feel the subshell of low energy, which is this one, and then will go towards the right side, which is high energy. So The electron will first feel 1s, then 2s, then 2p, then 3s, then 3p, then 4s, and so on. Because the energy here, it is to be noted that the energy of 4s is lower than 3d. So therefore, electron will first feel 4s instead of 3d, because the energy of 4s is lower than 3d. Now let's come towards the atomic configuration of the first 18 elements, which will be from hydrogen towards argon. So let's see, in case of hydrogen, we know that it has atomic number is 1, so its atomic configuration will be 1s, 1. It has only one electron, so it will go to the first lower energy, which is s, so it will be 1s, 1. So similarly, if we see the atomic number of helium, which is equal to 2. 2 is the atomic number of helium, so its electronic configuration will be 1s2, because s can accommodate a maximum of 2 electrons, so that will be 1s2. So the helium electronic configuration will be 1s2. Similarly, lithium. Lithium has atomic number 3, so its electronic configuration will be 1s2, 2s1, because in S can accommodate a maximum of 2 electrons, so 2 electrons will be accommodated in 1s, and the next third one will go to 2s, so therefore its electronic configuration will be 1s, 2s1. Similarly, beryllium. Beryllium has atomic number 4, so you can say that the electronic configuration will be 1s2, 2s2. So here the 4 electrons will go towards the S of shells, and both the 1s and 2s are completely filled. Similarly, the electronic configuration, if you see the boron, boron has atomic number 5, so its electronic configuration will be 1s2, 2s2, and 2p1. Because we cannot put this one electron into this, because S can accommodate only two electrons. This 2 1. So the third one, the fifth, we can say the fifth one will go towards P, because the P orbital is the next one, which electron will go. So we see that boron has atomic number 5, so the 2 electron will be go here, 2 will be go here, this will be 4, and 1 remaining will be go to the P orbital. P orbital. Similarly, carbon. If you see carbon has atomic number 6, so its atomic configuration will be 1s2, 2s2, and 2p2. 1s2, 2s2, 2p2, 2p2. So this is the similar case like this. One S has accommodated 2 electrons, similarly 2s has accommodated 2 electrons, and the remaining 2 electrons will be go to the p orbital, which is in which we can write here 2p2. Similarly, in other cases we can say that if you see the nitrogen, which has atomic number 7. So in case of nitrogen, the atomic configuration will be like this: 1s2, 2s2, and 2p. Here we will put 2 and 2 is equal to 4. The 3 remaining, so we will put 3 here. So 1s2, 2s2, and 2p3 will be the atomic configuration of nitrogen. So similarly, oxygen has 8 electrons. So we can say that 1s2, 2s2, 2p4 will be the electronic configuration of oxygen, and so on. Similarly, if we see the electronic configuration of argon, we can say that argon has atomic number 18. So its electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3s2, and so So we see that there is 1:2, 2 electrons, 2, 4, and 2:2, 2p6, so 10, and it is a team. So here will be 3p8, 3p8. This is the electronic configuration of argon of the last one. Now, if we see that sodium, if we take a sodium, this is atomic number 11. It means that sodium has 11 protons, 11 protons and 23, you say 23 neutrons. Because its mass number is 23. This is the case for the way we say that this is 12. We say that sodium has mass number is represented by A, 23, and atomic number represented by Z, which is 11. So sodium has 11 protons and 12 neutrons. So we can rewrite the electronic configuration of a sodium atom like this. In case to write the electronic configuration of sodium, we know that sodium has 11 protons and 12 neutrons. So this 11 protons will be equal to the number of electrons, which will also be 11. So when we write the electronic configuration for all the 11 electrons in our metals and underneath this sodium atom, in writing the electronic configuration for sodium, the first 2 electrons will go in the first orbital. So we will say the first 2 electrons will go in the first orbital. This S can accommodate only 2 electrons. The next 2 electrons for sodium will go to 2s2, because also S2s can also accommodate to 2 electrons. S can have 2 electrons, so the next 2 will go to 2s2. The next section electrons will go to the 2p6, because P orbital can hold up P orbital can hold 6 electrons maximum. And then put so here if we count, this is 2, 2, 4, and this is plus 6 equal to 2 plus 2 plus 6 is equal to 10. So we have 11 electrons. The one remaining value go towards the 3s1, because this one electron is go towards this s3s, because the p can accommodate maximum 6 electrons, so it's completely filled. These are also completely filled s, so this will go towards 3s1. So the electronic configuration of sodium will be this 1s2, 2s2, 2p6, and 3s1. Similarly, if you see the electronic configuration of potassium, which atomic number is Z, is 19. 19 is the atomic number of potassium. So it means that potassium has 19 protons, and As, the number of protons is equal to the number of electrons. So we can say that it also will have 19 electrons. So we will distribute these 19 electrons in case of potassium in various subshells or in shells. So the electronic configuration will be like this. We will start from the low energy orbitals, 1s2, so 2. We count the same 2, 2s2. This is 2 plus 2 plus 2p6 plus 6, 2p6, 3, s2, this is 2, 2 plus 2, and 3p6, this is 6, and 4s2, 1. This is plus 1. So if we count this 2 plus 2, 4, plus 6, 10, plus 2, 12, plus 6, 18, plus 1, 19. So electronic configuration of potassium is being completed. This 1 is 2, 2 is 2, 2p6, 3 is 2, 3p6, and 4 is 1. This is the electronic configuration of potassium. So in case of potassium, we have noted that its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3s2, 3p6, and OS1. OS1. So if you see the atomic structure of potassium, you can say that if this is the nucleus, and this is a one shell, second, third, and fourth. And then say this is a K shell, this is a L shell, this is a M shell, and this is the N shell. So we will distribute the 19 electrons of potassium in this. So this K shell will accommodate 2 electrons, and the L will accommodate maximum of 8 electrons. This is 1, 2, 3, 4, 5, 6, 7, and 8. So we can say that the 19 electrons will be distributed in case of potassiums. We can say that this is a 1s2. So these 2 electrons will be accommodated here in this shell. In these S subshells, we can say the 2 electrons. So this one, 1 and 2. So the next one is 2s2 and 2p6. 2s2 and 2p6. So this one. So this will be accommodated. This is total of 8. 6 plus 2 is equal to 8. And this will be accommodated in this shell, which is L. L shell. L shell, the 8 electron, which is this one, will be accommodated in the S and P subshell. S and P subshells are here in this L shell, so it can accommodate maximum of 8 electrons. And we can say that these 3s2 and 3p6, the total can accommodate also 8 electrons. So this will be accommodated in the M, in this subshells, which is this one. In this M subshells, you can say in this M subshells can accommodate a maximum of 8 electrons. In the subshell S and P. So in M shell, there are also S and P orbitals, which can accommodate a total of 8 electrons, 2 in S and 6 in P. So the remaining 1 electron of 4s1, we can say it will be accommodated in N. In this subshells, like here, and the last subshells, in the last shell N. N can 4s1, 1 electron will be here in the N shell in S orbital. So we can say that 19 electrons will be accommodated in the potassium atomic structure in this way. In other words, we can say that we have the electronic configuration of 1s2. We can say that it's 2s2, 2p6. So it is again here to be mentioned, this is a nucleus and this is the K shell, and a K can accommodate maximum of 2 electrons. This is a 1, this is a second. So these 2 electrons will be in the S subshell, which is this one, 1s2. And the next shell is a L shell, which can accommodate a maximum of 8 electrons, which are this one. So in this L shell, the maximum 8 electrons will be accommodated in the L shell, in the S and P orbitals, and in the 2s2 and 2p6 form. So the 8 electrons will be accommodated here which we previously mentioned. This is second energy level against the L shell. Similarly, the next 8 electrons will be, which is this one, 2 plus 3 is 2 and 3p6, which is the third energy level. So the next 8 electrons will be, this 8 will be accommodated in the M shell, in M shell next to in the form of 3s2 and 3p6 form, or you can say that in the 3s and 3p are the dots or subshells, or you can say this is third energy, third energy levels. So total number of we have 19 electrons. So 18 electrons are accommodated in the up to the M subshell, and the last one and remaining so one electron is left of one electron is left for the N subshell, so it will be accommodated here in the form of 4s1. So you can say that this is the electronic configuration of potassium in case of 1s2, 2s2, 2p6, 6s2, 3p6, and 4s1. So this is the electronic configuration of potassium in case of potassium atom by regarding the distribution of electrons in various energy levels, shells and subshells. Similarly, if we write the electronic configuration for nitrogen, phosphorus, we will have for nitrogen, we have already written that this is 1s2, 2s2, and 2p3, because nitrogen has 7 electrons. Similarly, in case of phosphorus, has 15 electrons and protons, so this will have electronic configuration 1s2, 2s2, 2p6, so 3s2, you can say 2s2, 2p6, so 3s2 and 3p6. So this is the 2 and 4 is 10 and 12, and this will be 3. 3. This is 3. And this is 3 because 2 and 2 will be 4, will be 6 with 10, and 10 will be 12, and 12 plus 3 will be equal to 15. So this is the electronic configuration in case of phosphorus atom. So thanks for watching. Subscribe and share.